This is Professor Duresh, and this is part 2 of the 3-part video series on factoring trinomials. In part 1, we introduced the basic concept of factoring a trinomial when a, or the leading coefficient, is equal to 1. And now we're going to take a look at trinomials when a is not equal to 1. So, for our first example, it's going to be very different from the rest of the examples because it's going to have a GCF. So this is going to be example 4. And we're going to factor the trinomial 5x squared plus 10x minus 15. And so right off the bat, we can see that this term does not start with a simple x squared. In fact, it starts with 5. So when you have a leading coefficient other than 1, we say a is not equal to 1. Then we ask ourselves, is this GCF? Does every term in the problem divide by 5? In this specific example, the answer is yes. So to factor this, we take out the 5 from each of the 3 terms. That leaves us with x squared plus 2x minus 3. Now we can proceed with trinomial factoring when a is equal to 1. So we're looking for two numbers that multiply to be -3 that can subtract to be 2. The only numbers that multiply to be 3 are 1 and 3. So the question is, which of these numbers is negative to produce a 2? If you guessed -1, you're correct. We need the bigger number to be positive if the sum is positive. That leaves us with x minus 1 and x plus 3. And again, you can switch these around. You could put 5, x plus 3, x minus 1. Order does not matter as long as the factors are the same. For our next example, we're going to have another leading coefficient. It's not equal to 1. So we're going to have 3x squared plus 7x plus 2. And right off the bat, is this a GCF? Unfortunately, the answer this time is no, because 7 is not divisible by 3 and 2 is not divisible by 3. So now I need to think of numbers that I can put in these positions, the four spaces, that's going to produce this trinomial when I multiply them together. For 3x squared, I can do 3x times x. What are numbers that multiply to be 2? I only have 2 possibilities. 1 times 2, or 2 times 1. This is the guess and check method because I'm literally going to guess a pair, check if it works, and then guess the other pair if it does not. So let's start by checking. You see that? 3x plus 1 times x plus 2. That's going to get me 3x squared plus 6x plus 1x plus 2. Does this add to be the trinomial I'm trying to factor? Since it does, I know these are my factors. But what does it look like when it doesn't work? So let's check the other option. 3x plus 2, x plus 1. We would get 3x squared, 3x, 2x, and 2. When we combine like terms, that gives us 3x squared plus 5x plus 2, and it doesn't factor. These trinomials are always going to have a unique factored form. So if you're guessing and checking and one form works, that's going to be the only form that works. Let's do one more example using the guess and check method, and that'll conclude this part 2 of our video series. Example 6. We're going to factor. This one's going to be a little bit more challenging because we're going to have more factors to deal with. So let's factor 6x squared minus 19x plus 15. Now here we have way more possibilities than we did in the last one. For example, in the last one, the only way to make 3 was 3 and 1. But how many ways are there to multiply to be 6? More than one. So first we look at the 6, we go, oh, a is not equal to 1. The leading coefficient is not 1. Can I divide everything by 6? Is this a GCF? No, 19 is actually prime. There's nothing that divides evenly into 19 except 19 and 1. So we know we can't simplify this by factoring out a GCF. Then we go into the guess and check method. But instead of knowing for sure that it's going to be 3x and 1x, we don't know what product of 6 is going to work. It could be 3x and 2x, or it could be 6x and 1x. So we need to try a few different combinations. I'm going to leave myself a lot of space down here to put a few different guesses. So my first guess is going to be 3x and 2x, and my second guess is going to be 6x and 1x. Now let's talk about 15. 15 can either be 5 and 3, 3 and 5, 1 and 15, or 15 and 1. And I get that same list of possibilities over here. 3, 5, 1, 15, 15, and 1. Because this is the guess and check method, I'm going to plug in these numbers and I'm going to guess and check. So for my first one, let's try 5 and 3. Now some logic for you. I'm not going to put the 3 right here, because if I put the 3 right here, 3x and 3 have something in common. And we already established at the beginning that there is no GCF. For that same reason, I'm not going to put the 15 right here. In fact, I'm going to eliminate these two options because they produce a GCF. I think I can do the same thing here. 6 and 3 would have a common factor, and 15 and 6 would have a common factor. So that gives me a lot less choices that I need to check through. Checking out my signs, I see that I need them to add to be a negative 19, but multiply to be a positive 15. So right off the bat, to multiply to be a positive, but still have negative numbers, both numbers need to be negative. And so I can check. 3x times 2x is 6x squared. 3x times negative 3 is negative 9. Negative 5 times 2x is negative 10x. And negative 5 times negative 3 is positive 15. So I got really lucky on my first guess, because negative 9x minus 10x does indeed make negative 19x. That means my factors are 3x minus 5 and 2x minus 3. I can test just one other option, maybe in the other one, just to practice guess and check method. So 6x times 1x is 6x squared. 6 times negative 3 is negative 18x. Negative 5 times 1 is negative 5x, and negative 5 times negative 3 is 15. So we can see here. That negative 18 and negative 5x, these two x's aren't going to combine to be negative 19. So in the last part of the video, we're going to talk about a strategy that will work for factoring these without having to guess.